Our first challenge in number 11 is trying to figure out what shapes we get when we graph x equals 4 minus y squared and x equals y squared minus 4. One thing we could do to kind of get a sense of what these look like is just think about x equals y squared. So if I solve for y, I get two answers really, right? I get y equals plus root x and y equals minus root x. And I know what both of those look like. Square root of x looks sort of like that. Minus square root of x should be the mirror image of that underneath the x-axis. And so what we end up with is essentially a sideways parabola, which is kind of what you would expect, because it looks like the equation for the parabola y equals x squared, just with the letters switched around, right? So that all being said, if we look at x equals 4 minus y squared, we've got what changes? We've got a minus sign in front of the y squared, which is going to flip the picture over, and we've got a 4, which is going to shift this picture 4 units to the right. Okay, so we're going to start 4 units to the right, and then we can just plug a couple of points in, except now we want to plug in for y and see what happens in the x direction. If I plug in 1 for y, I get 4 minus 1, which is 3. If I plug in minus 1, I get 4 minus 1, which is 3. So I get a point there and a point there. Okay, what's another easy thing to plug in? If we plug in 2 for y, we're going to get 4 minus 4, which is 0. So we're there. If we plug in minus 2, we get the same thing. So now we get this sideways parabola flipped over and shifted 4 units to the right. So it looks something like that. All right, now how about y squared minus 4? So there's no minus sign in front of the y squared, so it's going to be oriented like this one. But now we're subtracting 4. So instead of shifting 2 units down, like when we're dealing with things in terms of x, we're going to shift our graph 4 units to the left. So we're going to start at minus 4, and then plug in a couple of y values and see what happens. If I plug in 1 for y, I get 1 minus 4, which is negative 3. Same deal for negative 1. If we plug in 2 or minus 2, we get 0. So we end up with something that looks like that, except maybe better and more accurate than this picture. Okay, something along those lines. Now, although it isn't super clear from the picture that I've drawn here, there's a lot of symmetry going on. So in every one of these quadrants, we have exactly the same shape, just kind of rotated and shifted around. But let's pretend that we don't recognize that symmetry. What do we have to do in order to set up an integral to find the area here? So I need a lower bound, I need an upper bound. These need to be in terms of y. And then I need to know what shape is to the right minus whatever shape is to the left, and all of this needs to be done with respect to y. So the first thing that we should do is figure out what these bounds are. And while we can tell from the picture in this case, based on the points we plotted, let's pretend that we don't see those intersections, and then we need to figure those out manually. How do we go about doing that? Well, we set the two equations equal to each other. So we set 4 minus y squared equal to y squared minus 4 and solve. Pretty easy equation to solve, right? We get 8 equals 2y squared. We get y squared is equal to 4. So y is equal to plus or minus 2. Okay, which is exactly what we have in our picture. So now we know that we're integrating from negative 2 to 2. Now the question is, what goes in the first set of parentheses, what goes in the second set of parentheses? Well, again, based on my picture, I can see that the parabola, the sideways parabola 4 minus y squared, is always to the right of the parabola y squared minus 4 over this interval from negative 2 to 2 along the y-axis. So I want to subtract the thing to the left from the thing to the right. Okay, so our setup should look like this. And that's really the hardest and sort of most important part of this whole process. Now it's just a matter of doing integration like we're used to. So I'm going to integrate from -2 to 2. We can start by simplifying a little bit just to make life easier when we're plugging in. Dropping parentheses, distributing minus signs, we get 4 minus y squared is negative y squared plus 4. If we combine some like terms, we're going to get 8 minus 2y squared. And that's about as simple as we can get it, so now we can integrate and then plug in. We're going to get 8y minus 2/3 y cubed. We're plugging in -2 and 2. So what does that give us? That gives us 8 times 2 minus 2/3 times 2 cubed minus 8 times -2 minus 2/3 times -2 cubed. Simplifying a little bit more, we get in the first set of parentheses 16 minus 16 over 3. And so that 16 comes from 2 cubed, which is 8 times 2, gives us 16. In the other set of parentheses, we have minus 16. And then what do we get? We get minus. Now we've got -2 cubed, which is -8. So we've got minus 16 over 3. Okay, just a little bit more to go. So we've got 16 minus 16/3 plus 16 minus 16 over 3. Right, so here we've got 1, 2, 3 negative signs, which gives us minus. And we've got 32 minus 32 over 3, which gives us a final answer of 64/3.